I am going over test 1, chapter 12. Give a geometric description that satisfies the given equations. So we do have two equations, x to the power 2 plus z to the power 2 is equal to 36. In 3 dimension, uh, this equation will give you a cylinder, and that cylinder is going to be along the y-axis, and the radius of the cylinder is going to be a square root of 36, which is 6. Y is equal to 9 is going to give you the equation of a plane that is perpendicular to the y-axis. So it's going to cut through the cylinder, and it's going to be parallel to the xz plane. So this is the z-axis. This is the x-axis. So this is called the xz plane. And then y is equal to 9 is going to be the equation of a plane that is perpendicular to the y-axis, but it is parallel to the xz plane. So you would have sort of, I'm just going to get rid of some of these here so it doesn't get too busy. Now, y is equal to 9. If this is 3, 6, and 9, you're going to have a plane here. This is a plane. So it is parallel to the xz plane. It's perpendicular to the y-axis. And then this x to the power 2 plus z to the power 2 is equal to 36 is going to give you a cylinder. That is going here along the y-axis. So this plane is cutting through here. As a result, you get this circle. So your circle is going to be located, is going to be parallel to the xz plane, and is going to be located at y is equal to 9. So the center of the circle is going to be at x is 0, y is 9, z is 0. That's the center of your circle. And the radius of the circle is just going to be the same as the other circles on this cylinder, which is radius of 6. So that is what you get. This is what you get when you graph these two equations. I'm just going to get rid of everything else, and this is what you get. Find the center and the radius of the sphere. So to find the center and the radius of the sphere that has this equation, you have to put the equation in a standard form. And to put the equation in the standard form, you have to rearrange the terms. So I'm going to put 4x next to x to the power 2 and 2z next to the z to the power 2, and I don't have any other y term except this one. So let's write this as x to the power 2 plus 4x. So that 4x moves here. Then I have plus y to the power 2. I don't have any other y terms. then I have z to the power 2 minus 2z is equal to 0. So we rearrange the terms, and then we are going to complete the square for these two and these two. And to complete the square is I am going to construct a trinomial, have three terms, so that I could write it as x plus something to the power 2, because this is a positive here. Then I want to complete the square here, so I can write this as z, because of this negative, minus some number here to the power 2. So I want to write this in this form and these two in this form, and then I have the plus y squared, and then I will have a number on this side. So that's my goal. That's called the standard form. And to do this, I want to find out, how do I write this as a trinomial? We take 4 divided by 2, and then we take negative 2 divided by 2, and then we square them. We square them and add them to both sides of the equation. So I take 4, it's a positive 4, divided by 2, I get 2. This is the number that is going to go here, positive 2. And then I square that, I get 4. I'm going to add a 4 here and then add a 4 on this side. The same thing with negative 2. I take the negative 2, I divide it by 2, I get negative 1. And that's where what goes here, negative 1. Let me just erase it for now. And then I take that negative 1, square it, I get positive 1. So then I'm going to add 1 here and on this side. So that's what I'm going to do. I get x to the power 2 plus 4x. I add a 4 on this side, and I add a 4 on this side. Then I have y to the power 2 plus z squared minus 2z. And then I'm just going to add a 1 to this side and to this side. As I said before, these three terms can be written as x plus 2 to the power 2, and these three terms can be written as z minus 1 to the power 2. So if this is negative, this will be negative. If this is a positive here, this term will be positive. So, and then I have 4 plus 1 is 5. So this is my r squared, and then the center is going to be negative 2, because this is a positive 2, the center is going to be negative 2. No shifting on the y-axis, so that's going to be 0. And here you have a negative 1, you write it as positive 1, and that is the center of the sphere. And the radius of the sphere is going to be square root of 5. And that is called the standard form of the sphere. So next question, number 3, says an airplane is traveling in the direction 35 degrees west of north. So this is north. And this is considered west of north. Okay, so this is east, and this is west. So when they say west of north, so you go to north and then you go to its left, that's called west of north, and that's 35 degrees. At 300 kilometers per hour, find a component form of the velocity of the airplane. So I just want to write the velocity of the airplane that has this magnitude and this direction. So magnitude of the velocity, if v is the velocity vector, this would be the magnitude. And then you have to multiply it by cosine of some angle theta, that's the direction I, plus magnitude sine of theta j. And this is the velocity vector. That's what we are looking for the I and the j component. We could also write it like this: velocity magnitude cosine theta, velocities magnitude sine theta, something like that. And that is called the, that's what we are looking for. So we already know the magnitude is 300. So we already know that this magnitude V is 300. Then we need to know what the angle theta is. So we have to find this angle theta and this angle theta. So what is that angle theta? So when you want to measure angles, if I want to measure this angle for this velocity vector, I have to start from the positive x-axis all the way to the vector itself. So that is the degree of this angle. From the positive x-axis to this north, which is the y-axis, that's 90 degrees, 90 and 35. That gives me 125 degrees. So 125 degrees and 125 degrees. Or you can change that to 300 and this to 125 and the same here, right? That's what you're doing. That's how you find the components of the velocity vector. So all you have to do is put this in your calculator, and I'm just going to round them to the nearest. This is going to be negative nearest whole number. That's what I will do, but read the problem and see how they want you to round your number. And then the other one is going to be 246. So you multiply 300 by cosine of 125, and you multiply 300 by sine of 125 degrees. Make sure your angles are written in degrees, not radian. So you have to maybe adjust your calculator and make sure the angles are in degrees, because that's what I have done here. And it makes sense that cosine is negative because your velocity vector right now is in here in second quadrant. And in second quadrant, cosine component, the I component, which is going to be the cosine, is negative. And this is your sine component, or the second component, your j component, is positive. So that's why you have a positive here and a negative here. Find the following for the vectors. So we want to find u dot v, we want to find the magnitude of v, we want to find the magnitude of u. So u dot v, all it is you multiply this 11 by 5. So when you multiply, when you take the dot product of two vectors, you just get a number. And what the number is, you multiply the I components, 11 and 5. Then you add it to. You multiply the j components, 2 times 12. And you multiply the k components, minus 10. I don't have a k component, so this is 0k, so I multiply negative 10 by 0. 11 times 5 is 55. 2 times 12 is 24. Negative 10 times 0 is 0. So when we add them, we get 79. That is u dot v. U dot v is 79. We are going to find the magnitude of v. So 11 to the power 2 plus 2 to the power 2 plus negative 10 to the power 2. That's how you find the magnitude of a vector. You take the I component squared plus the j component squared plus the k component squared. So 11 squared is 121. 24, 2 squared is 4. 10 squared is 100. Negative 10 times negative 10 is 100. So that gives us 221, 225. The square root of 225 is 15. So the magnitude of V is 15. And then magnitude of U, is going to be 5 to the power 2 plus 12 to the power 2 and 0 to the power 2. You don't need to write 0 to the power 2. So we get 25. 12 times 12 is 144. We get 169. When we add them, square root of 169 is 13. So magnitude of u is 13. Now, it says find cosine of theta. To find cosine of theta, you have this formula, u dot v. You need the dot product on the top divided by the magnitude of u and magnitude of v. You could put u first, v second, doesn't matter which one you put first. So we do have u dot v, which is 79. We have v, which is 15. And the u is 13. So 79 divided by 15 times 13. Let me get a calculator. And find out what 15 times 13 is. 195. So that's cosine of theta. If they ask you to find the angle, I believe this problem is just asking to find cosine of theta. Let me just make sure. Is the cosine of the angle between u and v is yeah, so it's just asking to find the cosine theta. So that's it. We stop here. If they ask you to find the angle, then you go theta is equal to inverse cosine of this number. And you have to do this, but it didn't ask for that. So then it says the scalar component of u in the direction of v. That's what we're looking for. So we want to find the scalar components of u in v direction, and that is the formula for it, u dot v divided by v. So if this is your vector u and this is your vector v, then if I go perpendicular from v to u, then I'm going to have this new vector. And that's what we're looking for. We're looking for the magnitude of that vector. So a scalar component of u in the direction, the scalar, is just asking what is the length of this vector. So vector v projection onto u is going perpendicular from this tip to vector u. So this is a new vector on vector u. So it has the same direction as vector u, but it's shorter in this case. So we are looking for that length. And that's how you find it. So we take the dot product of u dot v, which was 79 from part A, divided by magnitude of v, which is 15 from part A here. So that's what it was looking for. The projection, now it says find the vector. So this is the scalar for this vector. So this vector's magnitude is 17, 9, 15. If I want to find actually, I should have relabeled them. This is because I'm doing u in v direction. U in v direction. So this is vector u, this is vector v. So anyways, that's what we have. Now it says find the vector. We want to find this vector. We know the scalar, we know its magnitude, but then how do I know what the vector itself is? Well, it has the same direction as v. So all I have to do is multiply this scalar, this is a scalar, that is the length of this new vector, multiplied by the unit vector v. This is the unit vector v. The value of this unit vector is 1. So if I multiply this scalar, this is not a dot product, this is just a multiplication. So it's a scalar multiplication because v over its magnitude is a vector that has a length 1. And then I multiply this magnitude by it, so then I just get this new vector. So that's what I'm trying to find. I'm trying to find this vector. So I have its magnitude, I multiply it by the unit vector v because it has the same direction as v, and then I get that vector. So this is 79 over 15. And v over its magnitude, vector v is 11, 2, and negative 10. 11, negative 2, and 10. So that's my vector v, but then I have to divide it by the magnitude, and the magnitude of v is 15. So now this is the unit vector v. The length of that vector is 1. So now I do a scalar multiplication. I multiply this by every one of them. 79 times 11 is equal to 869. 15 times 15 is 225. So I multiply this 2, I multiply this 2. That's I. Minus. I multiply 79 by 2. 80 times 2 is 160 minus 2 is 158. 15 times 15 is 225J. 79 times 10 is 790. 15 times 15 is 225K. So this is the vector projection. So it's called projection of U1 to V. How much work does it take to slide a crate 27 meter along a loading dock by pulling on it with a 200 Newton force at an angle of 31 degrees from the horizontal? So because we are looking for work, the formula for work is distance vector dot product with force vector. So we take the dot product of these two vectors, distance and force. For our distance, we are going to convert this into a vector. So the distance is 27 meter and is going toward east. So I can write it as 27I plus 0J because it's just a vector going this way. Its magnitude is 27. So there is the angle here, your angle is 0 degrees. So you have a cosine of 0 degrees, that's your I component, plus sine of 0 degrees, that's your J component, times its magnitude, and the magnitude is 27. Cosine of 0 is 1, sine of 0 is 0, so that's why you get 0J, which is 0. So 27 times cosine of 0 is 27I. So this is the same thing as 27 cosine of 0I plus sine of 0J. Then we have the force vector. The force vector has this angle of 31 degrees from horizon, and the magnitude is 200. So again, we have 200, that's the magnitude, cosine of 31I plus sine of 31J. That's how this is the force vector. So I'm going to distribute this 200 and write it like this, 200 cosine of 31I plus 200 sine of 31J. That is my force vector. So now I just have to take the dot product. W is equal to, I'm going to use that for the distance vector, 27 I 0j dot product with 200 cosine 31 I 200 sine 31j. So we multiply the I, oops, when I write it in this manner, I don't need to put the ij, sorry about that. Oops. This was 27. I need to put these ij's. Okay, now that's correct. Sine of 30. So we multiply 27 by 200 cosine of 31 degrees plus we multiply 0 by 200 sine of 31 degrees. 0 times any number is 0, but we have to find the answer to 27 times 200 times cosine of 31. So 2 times 27 is 54. 200 times 27 is 5,400 times cosine of 31. So we need to find out what cosine of 31 is. And then multiply that, which is 0.857. I'm around to 3 decimal points. And then I multiply it by 5,500, 400. And I got 4628. 0.7. That's what I got. I just want to make sure that I have my degree here, cosine of no, I don't have the angle correct. Let me just make sure this is cosine of so yeah, this is correct, and this is in joules. The next problem is find the volume of a parallelopiped or a box that is determined by the 3 vectors u, v, and w. So when you want to find the volume of a box and you have the 3 vectors u, v, and let's say w, so these are the sides of the box. And what you're trying to find is basically this box. And this is what you are given. Somewhere in the space. Maybe this is, right now is a straight, but maybe this is bent. So anyways, we want to find the volume of such a thing. And what you have to do is you have to find the determinant of vector u, vector v, and vector w, and which is the same as the cross product of the vector u and v and then you take the dot product, because when you take the cross product of these two vectors, you get a vector perpendicular to both of them. And then you take the dot product of that with another vector W, and that is determined by finding the determinant of those three vectors. So that's what we are going to do. And to evaluate the determinant, first we have to form the determinant, and vector u is I plus j, so it's 1I plus 2j. So it's 1, 2, and then 0. So you write the I, j, k component for u. Then you write the I, j, k component for v. And then you take the I and j and k component for w, 1 and 0 and 4. So that's what I did. You're evaluating a determinant that is made out of the ijk component of u, v, w vectors. And to evaluate a determinant, we are going to write the first column outside, 1, 2, 1, 2, negative 2, 0. And we are going to multiply this diagonal, and this diagonal, add them up. And then we are going to, so let me do that first. So 1 times negative 2 times 4 is negative 8. 2 times 4 times 1 is positive 8. 0 times 2 times 0 is 0. These two cancel each other. You get 0 for the green diagonals. You are going to also calculate these diagonals. So 2, 2, 4. 4 times 4 is 16. 1 times 4 times 0 is 0. 0 times negative 2 times 1 is 0. So we add these, we get 16. And the way you calculate the determinants, you're going to get the bottom number first. You write it here. Then you put a subtraction sign, and then you put this number, 16. So we get negative 16. To find the volume, then we have to take the absolute value of that. So the absolute value of negative 16 is positive 16, and that is the volume of the box. Find a parametric equation of the line that is going through this point and is perpendicular to this plane. So I just want to remind you that if we have such an equation for a plane, then the vector that is perpendicular to this plane is 9, 7, negative 5. This vector is perpendicular to our plane. So we want to find the equation of a line that goes through this point and is perpendicular to the plane. So our line is also going to have the same vector as this one. So if this is our plane here, and this is a vector that is perpendicular to it, then we want another equation of a line that is perpendicular to the plane. So but it's going to through that point. Let's say that point negative 5, 0, 2 is here, or is here. Then we want to find the equation of this line. So since this line is perpendicular to the plane, it is parallel to the n, is perpendicular to this other vector. They're parallel to each other, so all I have to do is to write the equation of a line. I need to have the vector for it. So the vector, I just use vector n, but then I shift it so that it goes through that point. This problem is super easy because all you have to do is write 9t, 7t, negative 5t, that's for x, y, and z, and these are your points. This is how you find the equation of this line that is going through that point. negative 5 plus 90, 0 plus 70, 2 minus 5t. And since you have a 0 here, you can just write this as y is equal to 70. So this is the equation of the line in parametric form. Find the equation of the plane through these points. So this problem is going to be a little bit time consuming. Because what we have to do for this problem here, we are given 3 points and we want to find the equation of a plane for these 3 points. So there are various steps. First, we have to create 2 vectors, P naught, Q naught, and another vector P naught, R naught. So how do I create a P naught, Q naught from 2 points? I just go 2 minus minus 3, 2 minus, this is negative 3, so negative negative makes it positive, 2 plus 3 is 5i. Then I go 4 and 2, 4 minus 2, 4 take away 2 is 2 plus 2j. Negative 5 plus 3. Negative 5, I'm sorry, minus 3. Negative 5, negative 3 gives me negative 8k. So that's one vector. I create another vector here, P naught, R naught. So then I do the same thing. I am going to go 3 minus minus 3, because that number is negative. So 3 negative negative makes that 3 plus 3. So I get 6i. Negative 5, negative 2, negative 5, negative 2. That gives me negative 7j. Negative 5, negative 3. That gives me negative 8k. So I have created 2 vectors, P naught, Q naught, and P naught, R naught. Then what I will do next is I take the cross product of P naught, Q naught, and P naught, R naught. And the cross product of these 2 vectors, it gives me a third vector that is perpendicular to both of them. So if I take the cross product of these 2 vectors, that is to calculate the determinants when the first row is I, J, K, and the second row is going to be the P naught, Q naught components, 5, 2, negative 8, 5, 2, negative 8. The third row is going to be the P naught, R naught components, 6, negative 7, negative 8. And then to calculate this determinant to find a cross product, which is a third vector perpendicular to the other 2 vectors, I have to write this first column and second column one more time outside the determinants. And then take the multiply these. So 2 times negative 8 is negative 16i. 6 times negative 8 is negative 48j. Negative 7 times 5 is negative 35k. Next, I have to also multiply these. So I start with the I1 first. Negative 7 times negative 8 is 56i. My negative 8 times times 5 is negative 40j, and 6 times 2 is 12k. Oops, sorry about putting it, I meant to put it here. Okay. Now, lastly, I have to write this as, I have to write these guys, minus 16i, negative 48j, negative 35k. Then I have to subtract, and then I have to write these, 56i minus 40j plus 12k. So pretty much we're doing algebra, looking for like terms. First, I'm going to distribute the negative. This negative turns that 56 to a negative. So let me get rid of that and turn this to a negative. Negative times negative makes that positive, and negative times positive makes that a negative. So now I collect like terms. Negative 16 and negative 56. I have to add 6 and 6 is 12. So I get negative 72i. I have to take the j components, negative 48 plus 40, so I end up subtracting, I get negative 8j. Negative 35 and negative 12, both are negative. I add both of them, and I will get negative 47k. And then this vector is perpendicular to both of those vectors. So once I have, right now, what I have is a vector that is, I want to take the dot and let me call this vector n, little n. This n is perpendicular to both P naught Q naught and P naught R naught, and P naught R naught and P naught Q naught are on a plane that we're interested in. So in order for me to find the equation of the plane, I take the dot product of n, and I use the P naught, and I go and I create a vector that is P naught and another vector P, where P is every single point on the plane X, Y, Z, every single point on the plane X, Y, Z, some X, Y, Z. So if this is my plane, and this is vector n, and this is P naught here. So then I take this P naught with this point XYZ, or this point XYZ, and this, and this, and this, and this. So then as a result, if I take the dot product of this vector with all these vectors on this plane, the dot product should equal to 0, because this n is perpendicular to all of them. So how do I create this vector? P naught is given to us as negative 3, 2, and 3. So let's create this vector, these vectors. All these are x, y, z's. So we go x minus minus 3 becomes x plus 3. Y minus 2, z minus 3. So these are my vectors. And then I take the dot product of these with n, set it equal to 0, and that is the equation of our plane. So what is n? N is negative 72 And if I take the dot product of this and this vector, because that's n, negative 72 times x plus 3 plus negative 8 times the other component plus negative 47 times z minus 3. Set it equal to 0. So this is my vector n. And I took its dot product with this other vector p naught. So positive and that negative cancel each other, and that becomes negative, and these cancel each other, it becomes negative. So this is a negative here, and this is a negative here. So that is one form, but I also want to simplify this, so I distribute negative 72 x, negative 72 times 3, I get 216. Then negative 8 times y is negative 8y. Negative times negative is positive 8 times 2 is 16. Negative times positive is negative 47z. Negative times negative is positive. Lastly, let's add these guys, constants, and move them to the other side. So I have 16 and 141. And then 157 and 216, I subtract. So I get 59. It is a negative 59 because negative 216 plus 16 and then plus 141 gives us negative 59. We add 59 to both sides. So the equation is going to be, this is gone, this 0 becomes 59. And that's what you will put in my lab math. Number 9 says find angles between the two planes. So in order for us to find the angle between two planes, we know that each plane has, if I have this, oops, if I have this plane here, it is going to have a vector perpendicular to it. And let's say if I have another plane here, and this plane also has a vector perpendicular to it. So if I find the angle between the two perpendicular vectors, between the two vectors that are perpendicular to our plane P1 and P2, then this angle is going to be the same angle as the angle between the two planes. So all I have to do is find that angle. That's what we're trying to do. So if this one is N1 and this other one is N2, then I want to find the angle between N1 and N2. And to find the angle between N1 and N2, there is the formula cosine of theta is equal to N1 dot N2 the dot product of the two vectors divided by their magnitudes. And then once I find that, I take the inverse cosine of both sides. So then in order for me to find the angle theta, I just find the inverse cosine of whatever number I get here. So what is N1 for each plane? So to find N1 for this plane, I have 1, 2, and since I don't have a Z, I get a 0. That's N1. And for this one, the other plane, I have 5, 4, and 7. 5, 4, and 7. So 5, 4, 7 is perpendicular to this plane. 1, 2, 0 is perpendicular to that plane. The dot product of these two vectors divided by the magnitude, it's going to give me, I will plug it in here and I will find the angle between them, this angle theta. So let's find the magnitude, their dot product first, N1 dot N2. We multiply 1 by 5. Plus, we multiply 2 by 4. And 0 times 7. 0 times 7 is 0. 1 times 5 is 5. 2 times 4 is 8. 5 and 8 is 13. So we get 13. Then we want to find the magnitude of N1. It is 1 squared plus 2 squared plus 0 squared, which is 5. Square root of 5. Then we want to find the magnitude of N2, which is 5 squared plus 4 squared plus 7 squared. 25, 8, 49. So 49 and 8 and 25. 8 and 9 is 17. 17 and 5 is 22. And 4, 6, 7, 8. And we get 82. That's the magnitude for N2. And now we put this on the numerator. The magnitude square root of 5 times the square root of 82. And that has to go into the calculator. So let me see what I get. I need a calculator here. So we are going to divide and then one more time divide by square root of 82. Um, 13 divided by parentheses the square root of 5 . So what I did was, if you're using your calculator, you have to put 13. I put a division sign, I put a parentheses. And since they both have a square root, you can put them under the same square root like that, and then do the division. And then I get 0.642024. And then I just want to find the inverse cosine of that. So this calculator. I don't know how to use this calculator to find the inverse cosine. So I am trying to find that. So now I find the cosine inverse of, let me just clean this up a little. So we want to find inverse cosine of that. And I'm getting 50 degrees 0.06 rounded to 2 decimal points. That's what I'm getting about. That's the angle between the two in degrees. Question number 10 and 11, the last two questions says match the equation with the surface and identify the type. So when you have x to the power 2, z to the power 2, some constant here, c1 and c2 is equal to some number, let's say c3, anything like that, or this is y to the power 2, z to the power 2, or y to the power 2, x to the power 2. Any of these combination, you have only two terms and both are being squared is equal to a constant, you are going to have a cylinder. So this is a cylinder. But then how do you define what the shape looks like if they ask you to graph it? So, and you need to eventually graph these functions for integration purposes for you to find the boundaries. So it's important that you be able to have an idea how to graph these functions or these surface, these equations, because sometimes they're not functions. Anyways, this is going to produce a cylinder. This cylinder is going to be along the x-axis because I don't have any x, I only have y and z. So for any x, this equation is true. So if this is z, y, you're going to have an ellipse. And how do you find what are the points on the y and z? Just divide both sides of this equation by 36. So 25 y to the power 2 plus z to the power 2 equals to 36. You divide every term here by 36. This is the same thing as saying divide both sides of the equation by 36. This becomes 1. And for this part, instead of having it at 25 over 36, you can flip the number and put it in the denominator here like this, 36 over 25. They're the same thing. So what that tells me, it tells me the equation, I have the equation of an ellipse with the major axis at, on the z-axis, 6 units going up and 6 units going down because the square root of 36 is 6. And a square root of 36 over 25, that's your minor axis, that is going 6 over 5 to the left and to the right on the y-axis. So if this is 6/5, and if this is 6 units here, so you have this kind of ellipse here. And then you do this all the way on the x-axis. So you have the same thing here. So that is the kind of cylinder you get. So you're just going to have a cylinder along the x-axis. So then the next problem says we have y to the power 2 plus 4z to the power 2 is equal to x to the power 2. This is going to give you a cone. And you have to know where this cone is going to be located. Is the cone going to be along the z-axis, x-axis, or y-axis? So for this problem, what we are going to do is a tracing. So if I let for instance, y equal to 0, then I get 4z squared is equal to x to the power 2. If I solve for z and the square root both sides, I get z is positive negative 1/2 of x. I divide both sides by 4, and then you take the square root of both sides. This is what you get. If I let z equal to 0, then I get y squared is equal to x squared. If I solve for y, I get y is positive negative x. So if I trace this graph with respect to z and y, this is the y-axis, this is my z-axis for the first one. I'm sorry, with respect to, sorry about that, I have this equation. This is my x-axis. So I just get these two lines. And if I graph xy, if I have the xy plane, I want to put the xy plane this way. Oops. I want to put the xy plane on the ground like this. This is my x-axis, and this is my then you also have the two lines here. So then what happens when you let x equal to 0? If you let x equal to 0, you get y 0 and z 0. But if you let x is equal to 1, when x is equal to 1, you are going to have an equation of an ellipse. So this is your z-axis, this is your y-axis. And you are going to have an ellipse when x is equal to 1. You are going to have an ellipse here. If you let x is equal to 2, you will have another ellipse. If you let x is equal to 3, you will have another ellipse, and so forth, right? So you're just going to have, and then if you, what you will get is going to be a cone, and this cone is going to be along the x-axis. So you will have a graph that looks like that. So these are your lines that we got from here and here, here and here. And that is the cone that is going to be along the x. So you have x isolated. That's why your cone is going to be along the x-axis. So this cone is called an elliptical cone. And that was the last problem.